Hello everyone. My name is Ritesh Kosta and I am a software engineer with expertise in full stack development. Over the years, I have worked on multiple projects involving expertise applications, database management, and scalable web solutions. I will take you on a journey to learn Java from absolute basic to advanced concept, whether you are just starting out or looking to strengthen your Java skills. This course will help you build a strong foundation and develop real world applications. We will cover everything from Java fundamentals to principal data structure, multi-threading, exception handling, frameworks like Spring Boot, and much more. My goal is to make Java very easy to understand and help you apply it effectively in your project. Let's dive into the world of Java and start coding. Now comes to the today's topic: what is Java, what is OOPS, and what is Java architecture and its components. Let's move to first topic: what is Java. Java is a platform independent, high level, class based, and object oriented programming language that is widely used for building web applications, enterprise software, mobile apps, and much more. Why is Java special? There are some reasons: platform independent, secure and reliable, and versatile. Now comes to the platform independent. Java program can run on any operating system like Windows, Linux, and Mac OS as long as the Java virtual machine is installed. Secure and reliable. Java provides built-in security feature, making a trusted choice for enterprise applications. Versatile. Java is used in multiple domains from mobile apps to large-scale web applications. Now, understanding a platform independence. Java follows write once, run anywhere principles. This means you can write Java code once and it will run on different devices without modification. Then, how is this possible? When you write Java code, it is first compiled into bytecode means .class file. This bytecode is not specific to any operating system. Instead, the JVM translates it into machine code or the specific platform it to runs on. This is why Java is portable and widely used in different environments. What is object-oriented programming? Object-oriented programming is a programming style that uses objects to design software. Instead of writing large block of code, we organize everything into objects, making programming easier to understand, use, and maintain. There are some key features of object-oriented programming. Reusability. Write code once and reuse it in different parts of program. Modularity. Code is divided into small manageable parts. Scalability. Make it easy to build large and complex applications. There are four pillars of object-oriented programming: encapsulation, inheritance, polymorphism, and abstraction. We will explore these concepts in depth later, but for now, just understand that OOPs make Java more efficient, reusable, and structured. Let's move on to the next topic: Java architecture and its components. Now, let's break down the architecture of Java and understand its main components. First is JDK, JRE, and JVM. The JDK is a complete package for Java development. It includes JRE, Java, and development tools. JRE requires to run Java programs. Java compilers converts Java code into bytecode, means .class file. Then development tools, debuggers, profilers, and other utilities to help developers. What are the use cases of this? If you are writing, compiling, and debugging Java programs, you need the JDK. JRE. The JRE is required to run Java application, and it includes JVM, core library, In the JVM means Java Virtual Machine, the engine that runs Java White code. Core libraries, essential class libraries needed for execution. Now talk about the use cases. If you only want to run Java application, not develop them, the JRE is enough. Let's jump on the Java virtual machine. The JVM is the heart of Java. It executes Java programs and make them platform independent. Then how Java code runs in JVM? First, write Java code. We start by writing Java code in a .java file. Then compilation. The Java compiler, Java C, converts the source code into white code means plot class file. JVM execution, the JVM interprets the byte code and it converts into machine code for execution. Then machine execution. The CPU finally runs the translated code. Understand the Java virtual machine architecture and how Java programs are executed. When we write a Java program, it doesn't run directly on our computer's hardware. Instead, the Java code is first compiled into white code, which is a special format that the JVM can understand. The JVM then converts this byte code into machine code and allowing it to run on different operating systems like Windows, Linux, or macOS. This is what makes Java platform independent. As long as JVM is installed, Java code can run anywhere. Now, let's break down the different components of JVM. First, class loader subsystem. The class loader is responsible for loading Java class file into the JVM. Think of it like a librarian who fetched and organized books before they can used. It works in three steps: loading, linking, and initialization. Loading. It finds the load the .class file into memory. Linking. It verifies and prepares the white code before execution. Then initialization. It assigns memory to static variable and execute static block. Now, second, runtime data areas. It's also called the JVM memory. The JVM needs memory to store and manage data while the program is running. This memory is divided into different areas. The areas are method area, heap area, stack area, PC register, and native method stack. Method area, it stores class related data like method definition and static variables. Then heap area, it stores object and their instance variable. This is where memory is dynamically allocated. Then stack area, it stores method call details and local variables. Every method call sets a stack frame which is removed after execution. Then PC register keeps track the current instruction being executed. And native method stack, it stores method calls that are written in other languages like C and C++. You can understand why this example. Think of these areas at different room in a house where different type of data are stored. Then jump on the execution engine. Now, let's talk about how Java is actually executed. The execution engine takes the bytecode and convert into machine code. It has three key components: interpreter, JIT, and garbage collector. Interpreter converts bytecode line by line. JIT compiler means just-in-time compiler. Identify frequently used code and converts into native code for faster execution. Then garbage collector, it automatically removes unused objects from memory and free up space. Think of each execution engine as a chef who reads the recipe as white code and prepares a dish as machine code for the CPU. Then talk about the Java native interface. Sometimes Java programs need to communicate with non-Java code, like system level programs written in C and C++. The Java native interface allows Java to do this. Think of JNI as a translator that helps Java communicate with non-Java language. Native method library. This is a collection of precompiled native libraries that Java can use when executing native methods. Think of it as a toolbox filled with special tools that Java can use when needed. Now, let's quickly go over how Java code is executed step by step. The class loader loads the .class file into memory. Then the runtime data area stores variables, objects, and methods needed for execution. When the execution engine, interpreter, or JIT compiler convert white code into machine code so that the CPU can understand it. When a Java program use native methods, the JNI communicate with the native method library to execute them. Let's move on the conclusion. The JVM is the heart of Java. It ensures that Java programs are platform independent, optimized, and efficient. By understanding how Java works, you can write better and more optimized Java code. That's it for today's session. Thank you. And I hope you have a clear understanding of Java and its architecture.